This is going to be a brief video on types of crystals. The first types of crystal we're going to talk about is an ionic crystal. In an ionic crystal, lattice points are occupied by cations and anions. Now, they're held together, being cations and anions, by electrostatic interaction. They're hard, they're brittle, and they have a high melting point. There's lots of force in between these force of electrostatics. And albeit they are cations and anions, there are no free-floating electrons. So these are poor conductors of heat and electricity. Now, there are various structures that can be formed depending on the ions in play. Now, ions and ionic radius varies, from type of ion. So you can get all different types of packing in ionic crystals. But ionic crystals are subject to the same type of calculations we learned in our last section. For example, if I said how many Na and Cl ions are in each NaCl unit cell. Given that NaCl has a face-centered cubic lattice, there would be 4 total ions of sodium and 4 total ions of chlorine because of that face-centered cubic structure. Okay, you'd have to know that going in. So 4 and 4 agrees with sodium chloride's empirical formula. Now let's work with a problem with that. If I told you the edge length of a unit cell of sodium chloride, given that it's face-centered cubic, is 564 picometers, and I asked what's the density of NaCl in grams per cubic centimeter. To start out, you'd have to know the mass of the unit cell. Okay? So you're going to have to calculate the mass. The volume can be calculated directly from the edge length, because volume is edge length cubed. You can solve for that. How many Na and Cl ions are in a unit cell? And what is the total mass in AMU? So we see that there are 4 sodium atoms and 4 chloride atoms. So there's 4 times the mass in atomic mass units of sodium ions, and 4 times the atomic mass unit of chloride ions. There is this many atomic mass units in each unit cell. If we divide atomic mass units by Avogadro's number, we can convert AMUs to grams. So we have that many grams in a unit cell. If we took the volume of the unit cell, and we took that picometer edge length, and we converted it to meters, we would get this value for the volume. And so from the definition of density, if we took the mass that we found and divided by the volume, we would get this density. This is a bit of a tough problem. It involved a lot of calculations, but it is similar to the one that you did in your crystal structures video. So other types of crystals, there's covalent crystals. Now in covalent crystals, lattice points are occupied by atoms. They're held together by covalent bonds, and they're a hard, high melting point. This is a very ordered structure of covalently bonded substances. Examples of this, they're also poor conductors of heat and electricity. Diamond and graphite are examples of carbon bonding to itself. Carbon would form a covalent crystal. Another type of crystal is a molecular crystal. So instead of the lattice points being occupied by atoms, these crystals, the lattice points would be occupied by molecules. They're held together by intermolecular forces, and it's a really low order crystal. It's soft. It has a low melting point. There's not as much packing in a molecular crystal. They're also poor conductors of heat and electricity. Last type of crystal is a metallic crystal. And so each lattice point is occupied by atoms, but they're occupied by metal atoms. Metal atoms have free-floating electrons, so you form electron clouds between these lattice points. And so you get a range of properties from soft crystals to hard crystals, and from low to high melting points. but for sure you're going to get good conductors of heat and electricity because of those free-floating electrons. Examples of metallic crystals would be any metal. All right? All metallic elements. Examples, and I forgot to give examples of molecular crystals. That would be substances such as sugar or CO2 crystals, in which you have molecular crystals occupied by molecules. So like a sugar cube, that's a molecular crystal. A covalent crystal is like that of diamond or quartz. An ionic crystal is like the examples given at the beginning of this video. Here's a table giving an overview of the general properties of these different types of crystals. All right, that does it for our types of crystals video.